Hi everyone, welcome back to my channel. Today we're going to talk about another brain teaser problem which is based on probability. So here we have a bag and basically it contains 3 pancakes, okay? And pancake is like it's like a snack, but essentially it's like a baked bread in some form. And the 3 pancakes have certain characteristics. The first one being burnt on both sides, as you can see here. Okay. The second one is actually golden on both sides, probably good to eat. And the third one is somewhere in between, where one of the sides is burnt, but the other side is golden. Okay. So now the question asks us, it tells us that you draw a pancake at random from the bag. So we draw. So basically we are given that in the setup, we actually draw a pancake at random. And what we notice is the side that's facing us is actually golden. Okay. And so this is given in the question. And we are supposed to compute the probability, as you can see here, we're supposed to compute the probability that the other side of the pancake that we drew out of the bag is also golden, okay? So this is given, and we want to figure out, okay, for this particular pancake that we drew out, what is the probability that the other side is also golden, okay? All right, so again, it's a good time to pause the video and try to solve this question. And if you're not sure, I would say the hint is the Bayes theorem. And, I do cover the Bayes theorem in the Quant Essential series that's also on the channel, and the description is also going to be in the video. So do make sure to check it out. All right. All right. So I hope you got the answer to the question. In case not, that's okay. Let's try to solve this together. Okay. So, I mean, there can be a couple ways, and I think let's first quickly, just get the Bayes theorem out of the way. So Bayes theorem simply says that probability of event A happening, given event B has already happened, given event B has already happened, is probability of A and B happening together divides by probability of B. Okay. Now, this is actually conditional probability of A given B, right? This is joint probability of A and B happening, and this is unconditional probability of B happening. All right, so now this can also be written like this. Okay, so if you see what I did is basically I translated this formula to this, because if you have an unconditional probability of event A happening, which is here, and you say, okay, what is the product of event A unconditional probability of event A happening and the conditional probability of event B happening, given A has already happened, that basically means that you're making sure both A happens and B happens. First A happened, and then you're saying, okay, let's also make sure B happens when A has already happened. All right, so now let's try to think about, so this is the hint. I would say use the Bayes theorem in case you were rusty on it and try to solve this. All right, so I hope you got the answer, but in case not, let's now try to solve this. Okay, so I mean, let's try to set up like this. And I would say this is one of the interesting things to the question. Let's say E naught, or let's say EI is the is referring to the pancake, with I sides burnt. Okay, and I naturally can be from 0, 1, or 2. So what it says is just a way to reference or index the pancakes. So E is equal to 0 is going to be the one with both sides golden, as you can see here, and then E is equal to 1 is going to be the one that is going to be burnt on one side and gold on the other side. And E is equal to 2 is going to be the one that's burnt on both sides, okay? And I, of course, cannot be greater than 2 because the pancake is supposed to have only 2 sides. All right, so this is cool. And then I say A is the event that the side, that the pancake we drew from the bag had golden side facing us. Okay, so what is basically saying, it's A is the event that, okay, if you drew a pancake out of the bag and the side which you were looking at is actually also gold, and that's the event A. Now, look, one of the trickier parts of this problem is how you construct these events. Okay, how you basically structure this problem. This is the part where we take care of the structure, and I would say now after this the problem becomes very easy. So again, pause the video and make sure you get that right, and also, you know, put it in the comment box if you got this right afterwards, because it's very important. Okay. All right, now let's quickly go and just finish this off. So what we are essentially looking for is this, if you translate this probability which is being asked is, hey, what is the probability that the other side is also golden, given you drew a pancake and the side you were facing was actually golden. Okay, so what it's essentially saying is, if let's say, now let's think about this, if let's say you drew a pancake out and one of the sides you looked at was golden. Okay, great. Now the question is asking, what is the probability that the other side is also golden? That basically means you're looking at the pancake which is golden on both sides. That essentially is the probability you're being asked for. But it's not unconditional probability, right? Because look, if the bag, there's 3 pancakes and you're drawing anyone at random, then it would be 1 by 3, very easy. But there is a condition applied here. Condition is that you drew this pancake and you saw the one on the side is actually golden. So this changes things. So let's now translate this to the mathematical problem we have. So this is actually equal to the probability that it's E0, okay, given A has already occurred, right? Why? Because event A is saying that you drew the pancake and the side you looked at was golden. That has already happened because we have this here in the question, right? We have this, we have this here, right? And E0 is the pancake that's golden on both sides. And that is exactly the probability we're looking for, because you also want the other side to be golden. So P is equal to E0 given A is probability of A given E0 times probability of E0. I'm referring this formula here, right here. Okay, divided by the probability, the unconditional probability of A. Okay, so now we apply another theorem, which is basically law of total probability, and this is something we covered again in the Quant Essential series, so do make sure to basically check that out, most likely in video number 2. Okay, so now let's first apply the law of total probability on this unconditional probability of A. So I say probability of unconditional probability of event A happening. Now event A is, again, it says that you drew a pancake and the side you looked at was golden. So if I know, I can condition this on a bunch of things. I can say, okay, this can be if, let's say, we knew that okay, let me just first write it and then I'll explain it. Okay, so what we're doing is we're saying this unconditional probability of A can be partitioned into 3 separate events, right? These first event is, let's say you drew, now let's try to think this through. So, you took a pancake out of the bag. Now, it is possible that pancake is one of them. It's only possible, like, either it's burnt on both sides. This is E2, right? It is golden on both sides. This is E0, and this is burnt on one side and the golden on the other side. So this is actually E1. Okay, so there's only 3 possibilities here because we're only taking one pancake. So that's what you see here, right? And there's a plus sign here because that is essentially saying or. So either we are in this space, or we are in this space, or we are in this space. But because this process is happening randomly, so it can be that the pancake you pulled out could be either one of them. And that's why we're trying to find out that, okay, in either of the cases, what was the probability that you could end up in a situation where you took this pancake out and one of the sides was golden? Okay, so now let's try to do this. So E is equal to 0 is again the case where you have the golden on both sides. Okay, and then we're saying, okay, let's say you took the pancake out and this pancake was actually the one which is golden on both sides. So what's the probability that's going to be golden on one side? Well, it's going to be 1 because, it's golden on both sides by definition here. So this is 1, right, times the probability of picking this pancake which is golden on both sides. Now this is, you're randomly picking the pancake, so it's 1/3 plus Now let's go to the other case. Let's say if this was not the case, but this was some other case. Let's say E1, which is again burnt on one side and golden on the other side. So again, what's the probability of picking it out? It's 1/3. Now, what's the probability that, okay, now we are in this case where we said, okay, it's burnt on one side, right? It's burnt on one and golden on the other. Now, what's the probability that the face you're looking at is actually golden in this case? That's a very interesting point, because you took this pancake out, right? And it's gold on one side, it's burnt on the other side. But it's not guaranteed that, hey, you're going to pick it always from the gold side. You could also be in a situation where you pick this pancake out, but actually you were looking at the burnt side. So this is pretty random that which side you picked up, and therefore the probability that you actually see the gold side in this case is 1/2, because there are two sides, and we're picking this cake in a random fashion. All right, so now let's go to the third case. Third case is basically the pancake is burnt on both sides. Okay, and what's the probability that you see a gold face in this case? Well, it's 0, because, well, the pancake is burnt on both sides, so it's 0 times 1/3, and we can get rid of this. So if you add it up, this basically becomes 1/3 times 3/2, that's half, right? So the unconditional probability of actually picking up a pancake and looking at it and finding out that it's a golden side is actually 1/2. All right, so we got the denominator. Let's also think about the numerator. So the numerator is probability of A given E0 times probability of E0. And by this time, I think you can easily figure out this is nothing but term number 1 here, right? And if you see this term 1, I can directly substitute the value as 1 times 1/3. This is 1/3, okay? So the probability of E0 given A is nothing but 1/3 over 1/2. So this is 2/3, okay? And that is our correct answer. I hope you got to the answer. In case you did not, make sure you look at the solution, you take the hints and try to solve it. But if you could not, look at the solution and then sleep over it and try it the next morning as well. I think one of the most important things is how you structure this problem. And the second most important thing is this part, where you realize that, okay, even in the case where you pick up a pancake which is burnt on one side and the golden other side, it is not necessary you see the golden side. It is actually random with the probability half, right? So very interesting question. And again, thank you for your time, and let me know how you like this problem and if you want to see more problems like this. So I'll see you next time. Thank you.